Hello everyone, nice to see you all and many familiar faces in the crowd. Today we're going to talk about how we've scaled from one code base to 17 Android apps and millions of customers. A few words about me. My name is Manolis Spanoudakis. I'm an Android engineer here at NewDay since 2020. Before, I worked in a number of sectors like social media, transportation, healthcare. And you can find me on LinkedIn and Blue Sky using those QR codes. Don't worry if you don't get them. I'm going to show them at the last slide as well. A few words about NewDay, who we are. We are a consumer credit and technology company. We have 5 million customers and are responsible for about 20% of all the credit cards issued in the UK. We offer apps directly to consumers. Some of the brands we have are BIP and Aqua, and we also do indirectly through partnerships with merchants. We have high street retailers, airlines, and more. So this creates a unique set of challenges as we have to serve all these diverse customers through a single code base. Now a brief look at how Android looks like at NewDay. When I joined in 2020, we had a single app monolith, a minimal amount of unit tests. We had 14 apps, but they were mostly WebView based, and only 5 developers. Everyone was working on everything, and code conflicts were very common. Fast forward 4 years, we now have more than 40 modules. We have 17 apps with a lot more native features. We've doubled in size, and we have moved from Azure for our CI to GitHub CI. We have 3 cross-functional teams and 1 BFF team that's working to move our backend services so that they're easier to consume from our mobile apps. And now a brief look at the tools we use. Tools everywhere. We have Jetpack Compose, which we adopted about 2 years ago. Every new feature we build is in Compose, and we've also been migrating all the features to it. We're using OpenAPI, which is useful to create automatically networking interfaces and contracts. We use AI daily. We have GitHub Copilot, both in the Android Studio as well as on GitHub. I'm going to speak about this a little bit more later as well. We use Optimizely for our remote feature flags, which helps us do continuous feature development and switching features on and off in production if necessary. For our unit testing, we use Moke, and for our screenshot testing, we use Google's screenshot testing framework. For our UI tests, we use BrowserStack. We try to document as much as we can using mermaid diagrams and Confluence. Now, a brief look at the AI tools I mentioned earlier. We have had access to Copilot on Android Studio since, I think, September last year, which has been really useful in reducing the need for boilerplate code. Recently, the Copilot agent has been enabled, which actually writes code inside the IDE. It's really cool. And we have also been given access to the Copilot agent on GitHub. This works by, you just need to create an issue on GitHub, assign the agent to it, and it goes off, writes the code, creates a pull request, which then has to be reviewed by a developer before it gets merged. So nothing gets merged without a developer approving first. We have found that both of these tools greatly enhance our day-to-day jobs as developers and have cut down on our development time. So, what's the recipe for building 17 apps at scale with a consistent cadence? There are 3 critical parts. Testing, because efficient testing protects against regressions and guarantees we deliver quality. A good CI/CD system that automates as much as possible and frees up development time. And a good release management. When you have such a big number of apps, it can be really time-consuming to release them all. Automating the process is really crucial. So in this talk, we're going to see how we do all this in NewDay. Now, part 1, testing. The first thing that's critical when it comes to testing is having clear responsibilities. Unfortunately, the old saying that if everyone is responsible, then no one is responsible is true. At NewDay, we have 3 teams, and each is responsible for a number of features. They own the actual feature modules. And they are responsible for maintaining good code coverage for them. Developers are responsible for QAing their own features. And they have to commit unit, UI, and screenshot tests every time they make a change. Our QA engineers focus mostly on regression testing, which is to make sure that our releases are not broken before they get shipped to our customers. Maintaining clear responsibilities helps everyone understand what is expected from them and reduces friction between teams and individuals. Now, an opinion that may be a bit controversial. You do not need QA testing to merge your code. In the past, we used to have on Jira a column called QA testing, and everything had to go through it before it was good to merge. This created a huge bottleneck because our QA resources were limited. But because we did not have comprehensive testing, there was no other route to follow, and we had to go through this process. Today, we've established a culture of testing, which means that every piece of code is accompanied by unit, UI, and screenshot tests. This, together with developer testing, provides us with enough confidence to be able to merge code without the need of constant attention by a QA engineer. The result of this, we have faster feature releases, our developers feel empowered that their work is solid, and writing tests is a given. Obviously, there are still certain aspects that can be automated, like, for example, if you want to test deep links or activity death or configuration changes, manual testing is still required, and our QA engineers do help when it's necessary. Now, a quick look on how our testing flow looks like. We start with our developers writing code and tests and manually testing their features. Then our CI runs just the necessary tests for the changes and fails fast if our unit test coverage decreases or our screenshot tests fail. Our developers get notified and fix it as quickly as possible. Our UI tests run asynchronously using browser stack, and if everything goes well and the code gets merged, we have Jacoco publishing the renewed test coverage on the GitHub README. Now, anyone want to take to guess what's this? It's a testing pyramid. Unexpected. Yep, so this is how it looks like here at New Day. We've got obviously unit tests at the bottom. These are responsible for testing our view models, our use cases, our repositories, and various helper classes. Sorry. 85% of our modules have a test coverage of above 70%. Above, we've got two kinds of screenshot testing. We've got component screenshot testing, which is testing individual components, and especially the ones in our shared component library. And then we have above it feature screenshot testing, which tests whole screens or more complicated components. The aim of these screenshot tests is to catch changes in color, spacing, text, and subtler UI changes. At the top, we have UI tests. The aim of these is to test functionality. So if a dialog appears correctly, if a button does what is expected, and not so much about subtle UI changes. Now, security. Security testing is especially crucial for us because we're a company in the finance sector, so we're heavily regulated. Security testing happens daily, actually nightly, after a release is completed. We have two kinds of testing. We've got SAST, which stands for Static Application Security Testing, which is a form of white box testing, which is testing the actual source code or bytecode. For this, we use CodeQL, which is a tool provided by GitHub. And for DAST, which is Dynamic Security Application Testing, which is a form of black box testing, which is actually running the application and trying to find vulnerabilities in much the same way as a penetration tester would do, we use now Secure. If any issues are found, they are published on GitHub under a security tab, and they are picked up as top priorities from our developers. Our CI system creates Jira issues automatically, and then we also have some Grafana dashboards to be able to monitor these issues. Now, challenges we've been facing. Testing doesn't come without its challenges, especially screenshot testing. First of all, we have a lot of apps to test. So when you have 17 flavors, 17 apps, that's a ton of screenshot testing required. Also, because we're using build variants, we can only create one variant at a time. So it's not easy to test every possible flavor. So we're still trying to work out what's the best way to go around for this. We've been thinking of either moving our theming inside the main code, but that is not really desirable because we would expose unnecessary code to every brand, or use a test harness, which is an easier approach. Then we also got screenshot CI test variation, which is an issue that occurs when screenshots are generated from different operating systems. So a screenshot generated from a Mac machine is not the same exactly as one generated by a Linux machine. Especially this is noticeable with text aliasing. So for this, we are in the process of moving our CI system to Mac minis. We're in the process of setting up our in-house CI. So hopefully this problem will go away once that happens. Finally, for our UI tests, the problem we have is that they take a lot of time to run, and they run asynchronously right now on the cloud. Unfortunately, integration with Teams, which is what we use, is not great, and developers need to go and manually check whether the tests have completed and if anything is going wrong. So sometimes this gets missed among other priorities or meetings. Also, we get reports every day, but even they are sometimes hard to interpret. Like, for example, 292 of 373 builds run successfully. Oh, great. Did my build succeed? I don't know. I have to go and check. So now let's talk about CI/CD. CI/CD isn't greatly the most pleasant of tasks. It is an essential one. In fact, when confronted with the prospect of dealing with the CI system, the average developer will respond in one of two ways. Yes, in my previous life, I was a CI engineer. Or two, can someone else do it? However, this is how our pipelines, our main pipelines look like. This is for our PR builds. So the PR build pipeline is triggered every time there's a commit on a pull request. It runs all the necessary tests, prepares apps that point to our UAT system, and deploys them to Firebase app distribution. And then we have our nightly pipeline, which creates just the release builds, makes them ready to be released. Some of them are sent to New Day's App Store accounts. However, we do have some others that are sent to our partners' Play Store accounts because they want to have control over the release process. And at this point, it's good to mention the parallelism that we have achieved with our builds. By using modules, we have been able to parallelize the testing. So as you can see, all the jobs run in parallel, and it completes much faster. Worth noting, however, that the cost remains the same. Just because it runs faster doesn't mean it's cheaper. So after moving to GitHub Workflows, we quickly noticed that builds were taking a very long time, costs were ramping up, and we were adding more apps, so it was getting worse and worse. When we had to investigate what we could do to cut down on these wasteful operations. So we asked every pipeline to tell us what it did last week. Not really. We just had a look at what we could change. We found 3 areas where we could make improvements, and we went to war. Or at least our colleague Andres Martinez did. So, round 1 of the fight, fighting unnecessary builds. We currently have 3 variations of apps that we created from our code base. Credit product, and buy now, pay later product, and another one that is fairly different from the others. So just testing those 3 variations should be enough to cover the entire code base. However, what used to happen is we used to build everything, all the time, on every PR commit. So this was a huge waste of resources and took a really long time. So we decided to make the building process ad hoc. We introduced labels on GitHub, which allow us to build specifically the branch we want. And by just doing this, we cut down our build times by 50%. In some scenarios, we don't even need to perform a build if we, for example, update just a script. We also cut down on the usage of the most common developer excuse. My code is compiling. Round 2 of the fight, fighting unnecessary tests. So we used to run every possible test on every PR commit. This meant basically that we tested code that didn't have any changes, which was a waste of time and resources as well. One of the points of having a modularized code base is to be able to run just the tests you need, but we were not doing that. So the solution we came up with was a script that creates a reverse dependency graph. It means that every module maps its dependencies, and when a file changes, which we test the host module where the file was changed, plus all the modules that are consuming this module. This ensures that we test all the files with a dependency on our change, and we cut out tests that are untouched or unaffected. For example, as you see on that graph, library core is one of our very basic modules. Almost everything, almost every other module depends on it. If you make a change on library core, then library core will be tested, plus every other module that has a dependency on library core. So this led to a further reduction by about 45% in our build times. And some code, if you make a pull request that touches code that's not in a module, it's in the main app module, let's say, or is just a GitHub workflow, it's instantly ready to merge. And now, number 3, fighting the cache. I like to say that cache is king, and I did see that t-shirt over there, yes. But in our case, our cache was a bit of a lazy king. We thought it was a good idea to create a cache on every PR. However, we quickly found out that if a PR had just a single commit because there were no need for further changes, we gained no benefit out of it. And we had spent about 8 minutes to create it, 8 billable minutes. So we decided to change direction. We moved to a single cache. We build it every night together with our nightly builds. And this is then reused throughout the day from every PR build. The reusability is around 50%. This method has the disadvantage that as during the day more commits get added onto develop, the cache becomes less reusable. However, we found that this decrease in gains is mitigated by the fact that we do not build a new cache on every PR. So did we win the CI wars? Let's see. We managed to bring down our build times from around 40 minutes to 15 minutes. We decreased our costs by about 60%. We saved our developers a lot of time. And we managed to automate the release process. So I think we can say we won. Still working on it, though. Now, let's talk about the third critical component, release management. Releasing 17 apps on a weekly basis can be daunting, but it doesn't have to be. With coordination between product, engineering, and testing, it can be streamlined so that your developers barely notice. At New Day, our product owners are responsible for a large part of the release process. From moving builds from internal testing to production, from arranging the phased rollouts without needing developer intervention, we have freed up a lot of time from our developers to do more important tasks. Sometimes there can be unforeseen circumstances that can delay or even cancel our release. However, due to the fact that we have achieved a weekly cadence, a new release is always on the horizon, maximum 1 week away. So we prefer to wait for the next release instead of going and doing hotfixes. We have actually done away with the need for hotfixes almost entirely. Feature flags, one of the most basic things, most basic capabilities needed to release at scale. They allow us to merge code while we're building new features without having to maintain long-living branches that are prone to merge conflicts. When a feature is complete and tested fully, we can remotely enable it for our users. And if anything goes wrong, we can turn it off. So we can do graceful degradation of our apps. At New Day, we use Optimizely for our remote feature flags. We also have a developer screen, which is the one you can see, where our developers can turn features on and off. We're following a tri-state approach. The switch has first priority. If you turn it on or off, then the feature is turned on or off. Then the remote feature flag, which is... We're out of batteries? Or connection? All right, thank you. All right, we're back. So the remote feature flags, which are denoted by the cloud, they're fetched from Optimizely. If a remote flag is not configured yet, or we fail to receive it, we have some hard-coded values in the app, which are denoted by the mobile phone icon. So with this approach, we can always have a setting if necessary, and our developers can override it if they want. So with this approach, we have managed to increase our delivery speed and intervene quickly whenever we have an issue. Now, a brief look on how our releases look like. Our typical release candidate is created on Mondays. Then we start regression testing straight away for 2 days. On Wednesdays, we begin our phased rollout. And by Friday, we usually complete the release, etc. Now, sometimes there are unforeseen things like incidents. And sometimes you have to do a special release that requires users to upgrade. For this, it's essential to plan very well, if possible, and if not, keep it as quick as possible. As an example, at New Day, we have a certificate refreshes happening once a year, so we know exactly what's our time window, so we plan around it. Together with the fact that we have a weekly release, we can keep this at a minimum, and we can show the users the necessary update screen. We also have an on-call rota, so we always have a senior engineer at hand if necessary, if issues occur. As we integrate with a lot of third parties, sometimes this happens. So to summarize, what has worked for us? In testing, having clear responsibilities between teams and members has helped us reduce friction. Having trust in our tests. It's great to have tests, but it's good if you can get some benefit out of them, and having trust in them makes your decisions easier. We have reduced the involvement of QA engineers from our daily development, and this has helped us massively merge our code faster. For our CI, we have to make many changes over time to reduce our build times and costs. We have reduced the number of builds by using PR labels. We reduced the number of modules we test on every PR by using this reverse dependency graph. And we have moved to a single cache for all our builds. For releases, our QA engineers are responsible for doing regression testing, and this is critical. We use feature flags, both remote and local, to enable features and respond during incidents. Our product owners have ownership of the releases, and this has given a lot of time back to our developers. And finally, by having weekly releases, we can manage to ship faster and remove the need for hotfixes. So what does the future hold for us here at New Day? So we've got exciting changes on the way. The future looks bright. For a long time, we have been building and creating features focused on delivering what each brand required. So we're now transitioning into a model where we are building capabilities instead. So we're more able to serve features in a more modular way going forward. Regarding observability, although we have a lot of data, we still need to find ways of making them more useful. We have many backend systems and data in many places. We need to get them together, and that's a challenge. Our data analysts are working on it. Finally, we've got more apps coming soon. So there's always going to be more challenges. I'm going to leave you with a quote from Douglas Adams from the Hitchhiker's Guide to the Galaxy. The guide says there's an art to flying, or rather a knack. The knack lies in learning how to throw yourself at the ground and miss. Building apps is hard. The trick is to accept failures as you celebrate successes. Learn from your mistakes. Throw yourself at it. Don't be afraid. You're going to hit the ground a few times. Eventually, you will miss it. Thank you very much.